Hello students, today we will start a new chapter. This chapter is named as nitrogen derivatives or nitrogen derivative compounds. This lecture is presented by me, Panit Ghatak, your chemistry teacher. So let's begin. As all of you can see from the heading itself, this lecture will be on the basis of amines or amines. So let's begin. As you know, the most general derivative of nitrogen is amine. This amine has a general formula of RNH2, where al can be any alkyl group, that can be CH3 or even it can be hydrogen as well. Okay. Mainly, if this R is hydrogen, then it will be called as ammonia. It will be called as ammonia. Okay. And if this R is CH3, then what will be the chemical formula of that compound? The chemical formula of that compound will be CH3NH2, and this will be called as methylamine. Okay. And if the R is C2H5, that is ethyl, then it will be C2H5NH2, that is CH3CH2NH2, that is being called as ethylamine. Okay, so the general formula of the amine is RNH2, where R can be CH3, C2H5 or any alkyl group as well as hydrogen. Okay, and please be remember that the most general derivative of nitrogen is amine. Okay, so let's proceed. Now we like to know the classification of amine. Okay, so amine, any amine or any amine group can be classified in three types, that is primary, secondary and tertiary. If the nitrogen of amine is connected to only one carbon, then it is called as 1 degree or primary amine. Okay, if the nitrogen of amine is being bonded with two carbons, here this carbon dimethylamine, here the nitrogen is bonded with two carbon, then it is being called as 2 degree amine or secondary amine. If the nitrogen of amine or amine is being bonded with three carbons atoms, then it is being called as 3 degree amine or tertiary amine. Okay, so by this way we can easily classify the amine group. Okay, and there is one more type of amine group will be there, that is called quaternary amine, where the nitrogen group of amine is being connected with the nitrogen group of amine is being connected with four carbon atoms, then it is being called as quaternary amine. So we can classify the amine in the four types, mainly three types, that is 1 degree, that is primary, 2 degree, that is secondary, 3 degree, that is tertiary, and we can add one more type, that is called tertiary, where the nitrogen of amine group is being bonded with four carbons. Okay, so here you can see the methylamine is 1 degree, dimethylamine is 2 degree, and trimethylamine is 3 degree. Okay, so let's proceed. Here in this lecture, this is the introductory part of amine, or we can say as the nitrogen derivative chapter. Although this is an introductory part of this chapter, but we will discuss some more about the physical properties of amines. Here we know the amines tends to be gases for the lower molecular weight cases, for the case of methylamine and trimethylamine, but many heavier amines are liquid in the room temperature. So lower molecular weight amines are mainly gases, but whereas the heavier amines are liquid in room temperature. Okay, and one very noticeable thing about the amines is that they are they tend to exhibit strong odors. For example, some has fishy smell. Okay, I have given you some example of that so that you get an idea how to draw amine. Okay, this is the more complex type of amine. Okay, so 1,4-butane diamine and 1,5-pentadiamine. So both of these are having some order as well. Okay. Okay, so let's move forward to the next slide. Okay, so in the last slide I have already discussed that the lower molecular weight amines having lower attraction van der Waals force, that is why they are having gaseous state of matter, but whereas the higher heavier ones having the higher van der Waals force, that is why they are getting higher van der Waals force, that is why they are having a liquid state of matter. But if they are having the isomeric amines, that is the same molecular weight, then what happen? Then we have noticed that the boiling points decrease in the order of 1 degree amine has the highest boiling point, then 2 degree amine, then 3 degree amine. The reason behind is the decrease in the intermolecular hydrogen bonding. In the case of 1 degree amine, the intermolecular hydrogen bonding is higher, then 2 degree, then 3 degree. So the lowest intermolecular hydrogen bonding is happening in the 3 degree amine. So that is why, as the hydrogen bonding, intermolecular hydrogen bonding is lower, intermolecular hydrogen bonding is lower in 3 degree amine. That is why the boiling point of 3 degree amine is lower. Okay, because we know if the hydrogen bonding is stronger, please be remembered that higher the hydrogen bonding, higher will be the stability. Okay, if the hydrogen bonding is there, then stability will be higher. So we will need more energy. We will need more energy. So we need more energy. The energy means we can give thermal energy, that is heat. So we will need more heat. So more heat means more boiling point. The boiling point will be more. Okay, so please remember this chart. So hydrogen bonding means higher stability. Higher stability means we need to give more energy to break the bonds. So the energy we can give, that is the heat energy. So we need more heat. Okay, higher the heat means higher the temperature. So the boiling point will also be increased. Okay, so please remember this scheme so that you get a clear idea on that. Okay, so in this lecture I have discussed the general formula, classification, as well as the physical properties of amine. Okay, in the next day as well we can continue this chapter. Okay, in the next day we're gonna talk about the chemical properties and the preparations of nitrogen derivatives, that is amines. Okay, I hope you have understood this part very well. If you have any kind of doubt regarding today's class or today's topic, please ask me in the comment section below. So thank you very much.